In this video, what I would like to show is how a chainsaw runs in various stages of tuning, how it runs when it's tuned properly, especially the high jet. Chainsaws can be filled with wires, sensors, microprocessors, solenoids, things that help them run properly and adjust themselves for proper operation. But older saws don't have such things inside. Chainsaws of today are filled with electronics. But sometimes people tell me they've inherited an old saw, they got an old saw from their dad or their grandfather or something, and they wonder how to tune the thing. What exactly is going on inside the engine when this sound that you listen for occurs? A two-stroke engine fires every time the piston comes up, but if it skips a beat, that's called four-stroking. So I created a model that'll help show these concepts of what happens inside an engine when four-stroking occurs and how the fuel and air and exhaust flow through the engine. What I'm showing here is a plastic model that I created once before for demonstration of these properties in a chainsaw. Here we're doing a high-speed demonstration, so it involves this high-speed jet. And when we refer to jets, we're talking about these needle valves, these adjustments of the passageways through the saw. This is the low speed, this is the high, and we're going to assume that you've got your low-speed needle, your low-speed screw adjusted properly. You have your idle speed adjusted properly, with that butterfly nearly closed. But this is full throttle operation. So here's what's inside the carburetor during this demonstration. The saw runs terribly at first because we have this screw backed way out. The high-speed screw is way too rich. There's too much fuel coming in to the center high-speed jet, the main jet. We're going to show how the saw runs as you progressively tighten the screw so that air-fuel mixture at wide open throttle becomes more optimal. As you adjust the high-speed screw and lean the mixture, meaning that there's less fuel, more air, as you reduce the fuel, the saw is going to run better and better until the point that it cuts at the most power it can produce, but still operate with enough fuel for proper lubrication and cooling. Typically, the manufacturers give you a recommendation for how to set the high-speed screw. They'll tell you, okay, seat it all the way fully seated down clockwise until it won't go any further. You gently turn it all the way down. And then they'll give a recommendation of a certain number of counterclockwise turns, say, 1.5 turns or something. And that should be a good starting point. Well, we're going to start with like 3 turns out, or 3.5, and I'll show you that the saw runs absolutely pitifully until you reduce that fuel flow. And you can listen as we go for that four-stroking phenomena, which happens in a chainsaw. And toward the end, I'll describe further what happens during that four-stroking and why the saw sounds that way. Hopefully the audio will be good enough that you can hear that as we go, and I'll stop at certain points and describe what's happening. All right, unless you want to fumigate the woods for mosquitoes, I don't think you want your saw set this way. There's way too much smoke, too much fuel being inefficiently burned and kicked out the exhaust. You're getting a lot of four-stroking, blah, 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 gurgling, burbling sound, hesitation, very little power, low RPM, not great. The energetic hand signals were signals to myself so that I would know which part of the film was which. The 1.5 means that I have the high jet screw screwed out 1.5 turns from full seat. This is roughly what's recommended by the manufacturer, and this has to be adjusted based on temperature, humidity, altitude. If you have an older manual saw, you have to adjust this based on ear, basically, and RPM. So this is intended to show you the effects of turning these screws. You can see here the four-stroking reduces, the extra smoke is reduced, the RPM goes up, the saw has a lot more power. We're getting close to where it needs to be. Noticeable difference at this setting is the four-stroking that you hear at full RPM. In this case, when the saw is running wide open with no load, you hear a slight hesitation. Bop, 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 bop. When the saw is put down into the cut and a little bit of down pressure is applied so that the saw is loaded, the sound smooths out and you hear more of a sound. So it's a pop, 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 pop. Let's listen again. Now that we have the saw just about where we want it, let's crank it down just another quarter turn and see what happens. We'll go to 1.25 this time. You'll hear even higher RPM, better power, a little bit of four-stroking out of the cut, and full, smooth, powerful operation in the cut. That's what you want. The saw also has excellent throttle response. Do you want to know, Jimmy, what that sound? Do you want to know what that causes that sound? I think I have a pretty good theory about it. And if you watch, I think you may agree. See what you think about it. I think you'll enjoy it too. Jimmy does. There you go, Jimmy. Good boy, good boy, good boy. I got more than one comment recently that said that my background music was a little distracting while trying to learn these concepts. So I'll keep that a little bit subdued this time. What you see here is a two-stroke engine. Piston's in blue, cylinder is at the top in gray. Shown here is the intake port. Now you turn it to the side. There are ports underneath. Intake is shown in blue. That's for air. That's where the cool air comes in. The red is used for exhaust. That's where the hot gases escape the engine. Scavenging is the term used for the process of removing spent exhaust gases and replacing them with fresh air and fuel. So scavenging is the ability of an engine to evacuate the exhaust and keep the combustion chamber clean enough that fuel and air can mix and ignite on the next stroke. So these transfer ports and intake and exhaust ports are tuned and arranged in a certain way within the engine so that this scavenging effect takes place as efficiently as possible. Notice there are no valves in this engine. It's a piston-ported two-stroke chainsaw engine. As the piston moves up and down and passes the transfer ports and the intake and exhaust ports, it controls when the fresh fuel and air come in and when the intake happens and when the exhaust occurs. So the valves aren't needed in this case. This is a four-stroking theory for a chainsaw with no rev-limiting coil. In this case, the RPM limit is set by the ability of the engine to evacuate spent exhaust. This is where the term scavenging comes about. This is the spark plug, where you typically find it on a chainsaw. There's all sorts of science that I won't get into in this video about placement of intake and exhaust ports so that the fresh intake helps to push out the exhaust in the proper way to keep everything moving properly for maximum power, maximum performance. This is just a very basic model. We won't get into those fine details. Throughout the demonstration, I'll show these little spheres moving about. The red is fuel and oil, white is air, and black is exhaust, sort of like soot color. And here are transfers along the side of the engine. They go outside the path of the piston. As the piston comes down, it forces air and fuel upward from under the piston in the crankcase, up beside the engine, and up on top of the piston. Keep in mind this is a two-stroke, so there's no oil pump to move oil about. The oil that's in the fuel provides the lubrication. Keep in mind when the fuel and air comes into this engine through the intake, it first enters below the piston so that it can lubricate the crank bearings and the wrist pin bearings on the piston and the cylinder walls. It then transfers up on top of the piston for combustion. So this is kind of the valving operation of a piston-ported chainsaw. There are no valves like in your car engine. In most cases, orthogonal to, or roughly at 90 degrees to, the transfer ports are the intake and exhaust ports. The intake port is typically lower than the exhaust port. That's because when intake comes in, it has to go below the piston first, then transfer up on top of the piston. The exhaust port typically leads straight out to atmosphere, whether or not you have a functioning muffler. Shown here is kind of a conglomeration of air and fuel coming out of the transfer port. We're going to assume for this demonstration that the four-stroking condition is developing in the engine. And that starts with too much fuel being introduced into the engine. This is the beginning stages of the four-stroking condition, where too much fuel is introduced on top of the piston during the intake stroke. So you can see there are more red spheres than there are white ones. And in this model, I'm kind of indicating that there's too much fuel, that there's a higher ratio of fuel to air. And they're also shown a couple of black spheres indicating a little bit of exhaust left over, which is always present in the two-stroke. Okay, the rich fuel and air mixture moves upward toward the spark plug, along with a little bit of exhaust, and prepares for ignition. The piston goes up and compresses the air-fuel mixture. Combustion occurs with a little bit of a rich mixture. The spark plug fires, and the engine continues on. Here is exhaust after the ignition of an extra rich mix. The exhaust port opens, but the saw can't get rid of all the exhaust. As the four-stroke condition develops and the exhaust port opens, all of that rich, smoky exhaust attempts to exit the exhaust port, but the engine can't get rid of all of it. So it starts to kind of choke on the extra exhaust fumes. The black spheres are the exhaust, and they're going out the exhaust port. There's still one red sphere left, and that's to indicate the extra fuel that was left over that didn't burn. There are no white spheres shown here to indicate that all the air was used up and the combustion was incomplete. So it contains some extra fuel and some little bit of exhaust that's left over. So this is setting up the condition for four-stroking to occur on the next cycle. Okay, the piston goes down past the exhaust port, which opens up the transfer ports again. Again, it's introducing a typical charge of air and fuel, which is at a pretty good mixture as it comes in. However, what was left over from before was a little bit of fuel, extra fuel, and a little bit of extra soot and exhaust. So again, a mixture comes in that's just slightly too rich. You would find this condition when you lift the saw up out of the cut, running at full throttle. So the fuel to air mixture is even richer than before. Plus there's extra soot in there, which makes it harder for combustion to take place. So as the piston goes up and compresses the mix, this time it's unable to fire. The spark plug does its thing, but the fuel-air mixture does not ignite this time, so it skips a beat. It skips a stroke. There's no power stroke on this stroke because the air fuel didn't ignite. But the saw is still moving. The saw still has inertia, and it's continuing to rotate, and so it moves, and the piston goes down. After the failed combustion event, the exhaust port opens again. The exhaust, what little exhaust was carried up on the previous cycle is evacuated. Some of the fuel air mixture is evacuated, and some of the air is left behind where it didn't exist before. Since the spark plug had attempted to ignite the mixture, but it didn't ignite, there's no additional soot this time. There's no additional exhaust. It's only the air and fuel that was in there before. So as the exhaust stroke takes place, as the exhaust cycle So this time as the exhaust port opens, whatever leaves there helps to create a cleaner environment inside the combustion chamber. Okay, now the piston's going back up in a cycle that I call recovery, because this time I show only one black sphere indicating just a little bit of exhaust left over. And now there's a fresh charge of air and fuel, and it should be a little bit cleaner than the previous stroke. A little bit less exhaust, a little bit better ratio of air to fuel, because it was just charged again with a fresh charge. This time there's a more favorable mixture of air to fuel, and there's not so much leftover exhaust carried up into the mix. So this time combustion is available again, and the spark plug fires and ignition occurs. Shown here are the black spheres, indicating that complete combustion took place, or very near, so that the only thing left over is exhaust again. There are people online who will tell you to listen for that four-stroking sound, but I'm not sure a whole lot of people have a good theory or I'm not sure many people have a good explanation of what causes it. I think I have a pretty good theory about it. Knowing what's going on inside the saw, I think, will help you to diagnose problems with your saw in the future.